Hey, what's going on, guys? Let's do this problem right here. The question is asking a wait a minute, okay, a centrifugal water pump with impeller diameters of 14 centimeter and 32 centimeter outlet rotates at 900 revolutions per minute. The volumetric flow rate is 95 kilogram per minute, and also they are saying assume the tangential fluid velocity is equal to blade angular velocity, right? Both at the inlet and the exit. Calculate the power required to run the pump. So they are asking for the W. So this one can be calculated by calculating, the work done by the shaft multiplied by the angular rotational speed. So that's going to be omega. So omega we already know, but we have to find the shaft. So to find the shaft, they have provided the volume flow rate. That's AV. We can say Q also, 95 kilogram per minute. So this one also can be written as mass flow rate because kilogram per minute. So M is equal to 95 kilogram per minute, right? Mass flow rate. So this is going to be F shaft is equal to mass flow rate times the radius. So they have provided the diameters. So let's list all the given information. The first one. So if we have these uh, two inlet and outlet, right? Inlet, outlet, and inlet. So if I consider this one R1 and outlet R2 value, and let's see what we get. So first of all, inlet, they are giving that the diameter of inlet is 14 centimeter. So the R1 is going to be 0.7 centimeter. No, 7 centimeter. It's 7 centimeter, and then D2. So this is D1. D2 is going to be equal to 32 centimeter, and that is therefore R2 is going to be equal to 16 centimeter, right? And they have given the omega, that is in revolution per minute, 900 revolution per minute. And then we have this Q that we already put it here. So let's see. So this is going to be the work done by shaft, that's going to be equal to M times the mass flow rate times the radius multiplied by this velocity. So this is going to be R2 V2 T velocity due to tangential fluid velocity, that's V2 V1 T V2 T. So R2 V2 T minus R1 V1 T. And if we find this value, that's going to give us the work done by shaft. Then we have to multiply by this omega. So let's put all the values. So we have, so this also they are saying fluid velocity is equal to the blade angular velocity. So this is equal to R1 times omega. This is going to be equal to R2 times omega, right? So let's put all the information. M is equal to what? 95 kilogram per minute. So since this is in minutes, I had to convert into second. 95 kilogram per 60 second, right? Then we have R2 that is here, that is 16 centimeter. If I convert into meter, that's going to be 0.16 times V. Instead of V2, I'm going to put R2 omega. This is revolution per minute. Let's convert into radius per second because that's the SI unit, and we have putting in second, right? Second, so we have to make this one second. So this one is going to be 900 times 25 radians divided by 60 seconds. So that is going to give us 94.25 radians per second. So we have the omega. So instead of this V2, I plug this R2 omega. So R2 is, let's put the omega for, so 94.25 R2 0.16. So this is our first R2 V2 T. minus R1. R1 is 0.7, 0.07 meter times V1t R1 omega t. So let's put omega first. 94.25 multiplied by 0.07, right? And if we calculate this value, this one comes out to be 3.09 Newton meter. So this is the work done by the shaft. Let's use a different unit. Okay, T shaft. Work done by shaft multiplied by angular rotational speed is going to give us the power generator. So let's calculate the power generator. So we have the T shaft right now. So this is going to be 3.09 Newton meter multiplied by this angular rotational speed. So that's 94.25 radians per second, and that gives us, that value comes out to be, wait a minute, so 3.09 multiplied by 94.25, right? 25, that is equal to 291.23 watts, and that is the final answer for this question. I hope you guys liked this video. See you next time.